So this is a homework video for the homework 10 and the problem 2. So the homework 2 is that we need to collect the definition of the property of the statistical process. So the first is Hw10 stationary. So Hw10, a statistical process xt is called the WSS if the mean of xt is equal to the constant, and its correlation depends only on the difference of the t1 minus t2. And the sum of the property is that the mean of xt plus tau and x star t is equal to the r tau. So r and all r tau is equal to the mean of x t plus tau over 2 plus the x star t minus tau over 2. And the mean of xt squared is equal to the r0. That means the average power of a stationary process is independent of the time t. The second example is the independent increment process. So if the probability of xt_a minus xt_b smaller than xt1 and xt_c minus xt_d smaller than xt2 is equal to the these two parts, we know that for any non-overlapping intervals. So the third example is the Markov process. So xt is a Markov process if the past have no influence on the statistics of the future under the condition that the present is known. That means that for any n and t1 greater than t2 greater blah 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 greater than tn and t2 is known, so we know that the probability of xt1 smaller than xt2 and under the condition of xt2 equal to x2, xt3 equal to x3, xt equal to xt is equal to the probability of xt1 smaller than xt1 under the condition of xt2 equal to the x2. So the first example is the normal process. A process xt is said to be normal if the random variable xt1, xt2, xtn are joint normal for any n, any t1, t2, tn. That is this equation, and where xt equal to the here and x equal to here and the mean of xt, and this is here. So the statistics of a normal process is completely determinate in terms of its mean. It's the mean in t and the autocorrelation of rt1, t2 or autocovariance of ct1, t2. The fifth example is the strict sense stationary process. A real statistical process xt is a stationary in strict sense if its statistic is not affected by a shift on the time axis. That means that the process xt and xt plus sigma has the same statistic for any sigma. So the first property, so there are several properties for this. So claim 1 is xt if xt is SSS if and only if fx1, x2, blah blah xn, t1, t2, blah blah tn is equal to the fx x1, x2, blah blah tn, t1 plus sigma, t2 plus sigma, blah blah tn plus sigma. So any sequence of independent identically distributed random variables is a SS process. So claim 2 is that if we know that xt is SSS, then we can know that the density function fx xt is equal to the fx x. So and this is the third property. So this is a constant if this is a constant. So and also here, because it's only because there, so if because the time doesn't really influence the density functions. So here if x is the SSS, then the autocorrelation is rt1 t2 equal to the rt1 minus t2. And if the mean of x squared t exists, and we can write this equal to the tau, so the r tau equal to the r minus tau, then rt is an even function. So this is the prob process. The sixth example is the white noise. So definition of white noise is that when Vt is the zero mean white noise if the correlation of RUV T1 T2 equal to the Q T1 multiplied the impulse of T1 minus T2. So example 1. So if Zt is a Poisson process defined on the page 13 to 14. So then Vt to Dt minus lambda is a white noise with the Q equal to lambda, which is constant. So the theorem, if the input to a linear system is a white noise with the Rxs T1 T2 equal to the Q T1 input of T1 minus T2, then the mean of Yt squared equal to the Qt multiplied by Ht squared, so which is equal to the integral from minus infinite to infinite Q T minus alpha H alpha squared D alpha, and this is the average power of Yt. So the seventh example is the mean agonic process. So the definition is that a stochastic process Xt is called agonic if all its statistic can be determined from a single sample. So Xt is said to be the mean agonic if this limitation is equal to the mean of Xt, so in the mean square sense. And notice that the mean of Xt must be a constant, and the mean square sense means that the limitation to the infinite, the mean of 1 over 2t, the integral of minus t to t xt dt minus the mean square is equal to 0. And the theorem if Xt is the mean agonic only if and only if this is equal to the 0. And the eighth example is marginal, so this is not required in the homework, so I will not record this in the video. Thank you, that's it.